All right, so thank you so much for coming to Python Logging, a meditation on silent failures. My name's Jess Unrein. I'm a platform engineer with Sprout Social. I've been there for about a month. Before that, I was at ShiftGig, which is sort of like the Uber for bartenders, as they hate it when people call them that. And before that, I was a Dev Bootcamp graduate and a nonprofit administrator and a jazz pianist. So part of why I wanted to do this novice talk on logging is because I don't have a traditional CS background, and I've sort of had to learn things haphazardly, as I'm thrown into them on the job. So this talk is for people who have never encountered logging or know that it's important but aren't exactly sure how to get started. And logging was incredibly important to me because you hear so much about test-driven development, and unit tests and integration tests are, the way to go. But I think logging really gets a short shrift here. The first Python code base I ever worked on was a Flask application where we had, I think, probably 100% test coverage, and we were really proud of that. But after I'd been working there for about 6 months, our DevOps guy kept harping on us, like, why don't you have any logs? This is driving me crazy. Things would go wrong on the AWS servers, and we weren't really sure how to track it down. And so eventually I got put on the logging project. And so I asked him, well, what do you want me to log? And he said, the important stuff. And I mean, that's not a really useful way to get started. And so I looked at the Flask documentation. And the Flask documentation basically boils down to logging. Yeah, you'll probably want to do that at some point. And so it's a difficult thing to wrap your head around because, tests are fairly straightforward. They either work or they don't. What's the end goal with logging? Well, I like to think of it as the other side of the coin to testing. Testing tells you when things are working or not working during your development process. Logging tells you whether things are working or aren't working as intended in staging and production environments. The Zen of Python tells us that errors should never pass silently, but the Zen of Python doesn't make a distinction between errors and failures, and that's something that I think is really important. So what is an error versus a failure? An error is something that causes your code to blow up. Unless you've explicitly silenced it, it should let you know in a noisy way that things are going wrong somehow. So something should stop working because of an error. However, not every failure is an error. Just because your code doesn't scream at you doesn't mean that things aren't going wrong. Good logging and monitoring can help you detect failures that won't necessarily show up in a stack trace. So a question I get asked a lot is, shouldn't I just do better testing then? I might have 100% coverage, but that doesn't mean it's really covering all of the cases, right? And yeah, sure, if we all lived in a perfect world where we could anticipate everything that would happen in a production environment, better testing might work, but you can't always anticipate everything that's going to happen as a result of dependency changes, or maybe a server goes down, something like that. So that's where logging and monitoring comes in, because tests are really good at detecting the presence of a wrong outcome, not so good at detecting the absence of a right outcome. So, like I said, dependency changes can be a real pain. The last code base I was working on, we used to send out this email when users were registered, right? We'd send out a welcome email, but our users were employees, so they wouldn't necessarily start out as an active user. They might be a pending user. So we wanted to send out a welcome email in cases where they were initialized as active, and also when they were changed from pending to active. However, we were using SQL Alchemy to detect changes using the history object to figure out whether this was the case. However, when we upgraded from SQL Alchemy 0.9 to 1.0, they had an undocumented change in how they dealt with that history object. So the email stopped going out half the time. And we didn't know that for an embarrassingly long period of time until people started saying, I don't know how to set up my direct deposit information. You guys never got in contact with me. If we'd had more thoughtful logging from the beginning, we would have been able to detect that that users becoming active and welcome emails going out weren't matching up. So what is logging? Logging is record keeping for your app. It gives critical information about errors you might see, behaviors you don't see but should, and gives you clues to detect problems that you might not otherwise come across. Logging is really fantastic at letting you know what the state of your app was before you hit an error. And one thing that I really want to point out right now is printing to standard out is not logging. Printing should be for outputting information to users using a command line interface. It can be somewhat useful on the fly, checking during active development to make sure that things are as you expect, but it's not a suitable substitution for application or library monitoring. Logging should be methodical and collected in a dedicated file that isn't like filled with all of the random output of developers who were too lazy to delete their print statements when they got done with developing. Print also doesn't provide some key functionality that the Python logging module provides. So there are 3 key pieces of functionality that set logging apart from just printing things out and checking things on the fly. So those are level setting, file handling, and formatting. So logging levels are important because not every logging statement contains the same level of information. Transactional events and errors should be grouped differently. Grouping logical units together can help you keep track of what's going on, and if you know where things live, you're going to be able to diagnose problems much more quickly. So our logging levels are going to be not set, debug, info, warning, error, and critical. In general, it's not a good idea to use not set when creating logging statements. Not set is going to automatically go to your root logger, and if you don't know where that is, that causes a problem. So do assign your logging statements a logging level. Debug level logs should generally only be turned on in development environments. You might use them for something like recording the number of database queries that you executed in one function so that you can catch early on where inefficiencies might come up. Info level logs should be transactions that you want to keep track of but are expected and normal behavior inside your app. This might be something like user account registration or sending out a push notification. Warning level logs are something that don't break your application, but you want to keep tabs on. Something like unexpected user behaviors or edge cases that you know might come up, but you don't want to encourage and you might have to address in the future. For example, one of the things that we did at my last position was we crafted a reliability score for our employees. And we worked with the data science team to make sure that the statistical model was on a standard bell curve. So every time somebody had a reliability score in the bottom or top 10%, we would log that and periodically make sure that those fell within the same bell curve that we were expecting so that the score wouldn't necessarily change based on user behavior. Error and critical level logs should be where you find stack traces to point to explicit and noisy failures in your application. For example, failing to connect to your database would be an error or critical level log. So where should your logs go? Log files, like we talked about, logs shouldn't go to standard out. They also probably shouldn't go to standard error. Standard error can get really noisy, and you don't want to pipe things in there that aren't explicit errors in your program. It can make it really hard to find things when stuff is actually going wrong. So logs should go into their own dedicated files, and you can set these up using error handlers. So here I've shown you how to set up a basic logger with a handler. Oh, that's a little smaller than I thought, sorry. But so logging has, the Python logging module has a file handler available, and you can set the file that you want your logs to go into. You can also set the level of log for that handler, meaning that only log messages of that level or above will get recorded in that file. Another nice thing to note is that you don't have to have already created this file. Just doing this will create the info.log file for you. And when you put in log messages like logger info, helpful message here, or logger error, it'll output as just a string representation of whatever you put in. So you should be logging key transactions, errors, unusual behaviors, and anticipated edge cases. And the log messages we had down here were fine, but they were little better than print statements. Without formatting, we don't even necessarily know what level of log we were seeing. We just know that it was info or above because that's the level that we set the handler. There might be general information we want on every log that we don't want to write out every time because that's a pain. And so this is where formatters come in. So basic formatting gives us a little bit more information and an idea of what we have going on. So here we've crafted a formatter that will give us a timestamp, the name of the logger, the level name, and then the message, and output down there, again, as a nice string. So these string output logs are really nice to look through as a human. So I like them for smaller applications where you don't expect to see a lot of load. But when you get into larger applications, you'll probably want to think about some advanced formatting. JSON logs are my favorite example of advanced formatting because they can be consumed by other services to keep track of what's going on. The downside of JSON logs is they're a little bit harder to parse just as you're going through as a human. So it's really, personal preference which way you want to go. But I like JSON logs in general. There are several external libraries available that subclass logging.formatter and return JSON logs for you. There's one specifically for Logstash that you can install. And so things that you might want from a log formatter are what server did the original statement come from? Was there a user logged in? If there is, we'll always want to grab that user ID and put it in the log formatter so that you don't have to worry about plugging that information in every time. These are just ideas, but there's a wealth of information you might be leaving on the table that could be critically effective to debugging a problem. So we can also create our own formatters. I'm going to tweet these slides out, so if you want to see these later. I know that's a little smaller than I thought it was going to be. Oh, okay. Yeah. Well, I'm sorry about that, but I will tweet these out. And I'll also have my presenter notes. So if you want to take a look at these later, they will be available online. But this is an example of creating a myFormatter class that overrides the base class format function, and you can take in things like the log level name, a timestamp, the level, and any exception info. So here are the available attributes from the log record object that the Python logging module provides for you. Name, level number. I didn't go over level number, but you can also check by number rather than by name. That's a personal preference thing as well. You can also see the line number and the path name that the logging message originated from, which can be really great for figuring out exactly why you're seeing things. You can also pass in your own custom arguments. A nice thing to know about exception info is that it will default to none if there is no exception, so you don't have to worry about null checking on that. And you can also figure out the function that the logging statement originated from. One thing to be aware of func is that if that logging statement didn't originate from a function, it will blow up your logging statement. That one does not handle null checking for you. So I try to stay away from that, and if I think that the function that it's called from was important, I'll pass that in as a custom argument rather than relying on something that might blow my log up if I don't remember that it doesn't handle none. So logging is great, but overly noisy logs can encourage deafness. So we need to think about how much logging is too much, right? And this is not a very helpful solution, but it all comes down to personal preference, right? Because sometimes noisy logs can be useless until they suddenly aren't. In my last position, we were using a conditional task queue with Celery in conjunction with Flask, and we had annoyingly verbose log messages every time an app context was tearing down. But then we found out that Flask wasn't handling exceptions correctly in app context teardowns, and we would have never found that if it weren't for these annoyingly verbose logs. So one thing to note is you can always add log messages in and take them out. As necessary, you don't have to consider them like a permanent part of your development process if you just want to stick something in and try and figure out what's happening right now that's blowing things up. Another thing you'll want to think about is proper file handling because logs can start to take up a lot of space. So well, one thing that you want to make sure is that you aren't doing so many logs that it's slowing down your application processes. I've heard stories of that, and that's amazing to me that you would be logging so much that it would slow your application down, but it does happen sometimes apparently. And you also do hear about log files getting so big that they will start taking up too much disk space. Luckily, the Python logging module does offer us some solutions for this. We have a rotating file handler where we can set the maximum size of the file that we want to keep around, and we can also keep backups. So here we'll have a maximum file size of 20 bytes and up to 5 backups. Our alternate, okay, and our alternate one is a timed rotating file handler where we can set on what interval we want our logs to rotate over. So this one will every 2 days create a backup file and keep a maximum of 5 backups. Our available options are seconds, minutes, hours, days, and weekdays. I personally prefer timed rotating file handlers because if you know that your users were seeing a particular error last Tuesday, then you know which log file to look in as opposed to, did this happen 20 bytes ago? Did this happen 40 bytes ago? I think it's a little bit easier to manage, but if you do have a high traffic application, that can be a little bit dangerous to just assume that your log files won't get too big over a certain number of days or hours or whatever. So now that you have logs, what do you do with them? You start watching them. It can keep you up to date on your application's key transactions. It can warn you about those things like statistical models getting out of whack or users finding exploits. And again, this is where logging levels come back into play. If you use a monitoring system, you don't want your monitoring system telling you about routine level events. But if you use some more advanced monitoring systems, you can configure it so it'll tell you, hey, I haven't seen a user log in for 2 days. That seems not right. So there are a few systems that I really like. I like Logstash, Splunk, and Papertrail in general. And one that I particularly like, though, that I don't think gets a lot of attention is New Relic Insights. It is a paid service, but their Insights application allows you to put in custom parameters so you can create nice charts over time about the logging statements you are or aren't seeing. I love it for keeping track of notification volume. So big takeaways: testing is for development. Logging is for staging and production. Keep track of what's going on, understand what's happening in your application. Thank you so much for coming. I will make these slides available. They're on my GitHub, and I'll also tweet them out at JL Unrein. GitHub.com/thejesslee/talks. And like I said, I will tweet it out because it's a little bit of a long URL. Right. Oh, yeah, I have time for questions. What's up?
Why use like text files for logs instead of something like a database where I can search by like log level and like narrow down a time?
That seems like a lot of overhead to me for something that you should be constantly doing. Like you're going to run out. I mean, that's going to be a very large database. Also, I mean, logs are just text files, right? You can grep through them. And, you know, if you are managing your file rotation properly, it shouldn't be too onerous to grep through them, especially if you are aware of the keywords you've used in your messages. Yeah. Yep.
Addressing his point, we actually just tested this a couple of months ago. I forget exactly why, and the database was significantly slower, like 2 orders of magnitude slower than just writing to the text file. It was long enough ago. I don't remember what was driving us to it, but it was like, no,
Yeah.
we need that speed.
Oh, yeah. So the question was, why not just log messages to a database so you can look up by log level? And the comment was that this was actually tried not too long ago, and the database was 2 times as slow.
It was about that. It was significantly slower. You know, if something took, a second to run, once we switched just the logging to the database, it would take 3 seconds
Yeah, so it was significantly slower and caused performance issues. Anyone else? All right, well, thank you so much for coming.